Good evening, everybody. I'm Pallavi Gupta, and I'll be taking one of the three sessions of this course for NPTEL NOC24-ma18, the statistics and probability of R software. So this is actually, I'm re-recording the lecture because the live session was conducted yesterday, but it was not, due to some technical glitch, I was not able to record the session. So I am re-recording it, re-recording a quicker version of it, just quickly summarizing what all was discussed yesterday. And I'll just quickly brief you through how the course is going to progress. So let me just share my screen. All right. So the course Essentials of Data Science with R Software, the first course of this series, which is Probability and Statistical Inference. It's a 12-week course, and for every week, there are going to be 3 live sessions conducted in the week. They're going to be on Fridays, 6 to 8 p.m., Saturdays, 3 to 5 p.m., and Tuesdays, 6 to 8 p.m. again. We are 3 PhD students, 2 from IIT Delhi and 1 from ISC Bangalore. We'll be conducting them on different online platforms. I'll be taking the ones on Fridays, and these are some of the important links. You'll have access to these links within a day or two. So this is the link for the live session that's being conducted right now on Zoom. These sessions are going to be recorded, and the recordings are going to be uploaded to my YouTube channel. Any material that we discussed in these lectures would be uploaded to the Google Drive. This would mainly include the PPTs and the R code. Also, there's a discussion forum in the NPTEL page under the heading of Ask a Question. So any questions, any doubts that you have about the course, about the assignment, about these live sessions, or any suggestions you have, you can post it there. There would also be a feedback link for every week's lectures, so feel free to use those as well. The way the course is going to proceed is that on Fridays, a set of lectures is going to be released. So, and about in 12 days time, so next to next Wednesday, it would be a deadline to submit the corresponding assignment. And so one Friday you have the video lectures released. The next Friday, Saturday, and Tuesday, you're going to have these live sessions. And the Wednesday after that, you will need to submit your assignments. These live sessions are going to be more useful if you have already seen the lectures, because we would not be discussing everything that was covered in the lectures, but going for the main points. And we'll be practicing some questions. Starting the next week, we will also be discussing the previous week's assignments. So this is what the schedule looks like for the Friday session that I'll be taking. Since the course is going to involve a lot of coding, I will recommend that not just looking at the lectures, but also installing the softwares. So the first thing you would need to install is R. This has been shown a bit in the lectures, and it's very easy to follow. This is the link for it. You just identify your, so there is something called the mirrors. So basically R is posted on a lot of different pages, depending on, so it's hosted across a lot of countries. So ideally you can use any of the countries' mirrors. It is not necessary to use just of that of India or the nearest country. So choose the mirror and choose your operating system and just install R. Now, once you install R, the next thing you should also do, which would just give you a better picture of how R is working, it's a little more user-friendly, and that's this software called RStudio. Again, this is the website for it. The link which was talked about in the lectures, since the lectures are a few years old, that is now obsolete. So it's now hosted on this posit.co website. You can install it. And this is what the RStudio window looks like. So so this thing on the bottom left here, that's called the console. This is where all the commands are going to be executed. So whenever you are running a command, you're typing a command, you're running it, that is known as executing the command. So this greater than symbol is what's telling you that R is now ready to accept a command from the user. It is also called the command prompt, and it's sort of analogous to the command prompt you have for Windows. We will walk through the other three panes. I'll give you a demo and then we'll walk through that in the rest of today's session. So this is what it's going to look like once you have written a lot of things. All right. So just to mention that most of the videos you would see, the pre-recorded videos that sir has recorded, they would be using R. I would be using RStudio in my sessions. So it would give you an idea of both the platforms, and then you can choose which one works the best for you. So now I have this open with me. So this is what it would look like initially when you've opened RStudio. You have the console here, you have the environment on the left side. We'll see what this does. And then there are a lot of things happening in the bottom right here. So you can see here that you can just ignore these error messages from now. You have this greater than symbol. So now R is ready to accept that input. So let's begin by typing some simple calculations. Okay, so let's say we do a 2 plus 3 here. We do that, we press enter. Once you do, you get the output, which is 5. Easy. Likewise, you can do some more calculations. After addition, you can do subtraction. You can do multiplication, where you would use the asterisk symbol. You can also do division. There's also something called the exponent or the power. So you can do 6 to the power 2, that would give you 36. Another notation of doing this power is using the double asterisk. So a single asterisk means multiplication and a double asterisk means power. So you get the same answer like that. Right? Now, let's say I continue to do this. I would get a lot of statements, and I'll have a lot of commands. I'll also have their outputs written here. That if I want to share it with you, I will have to copy paste the whole thing, paste it in a Word document and send it across. A simpler way of that would actually be making a document of the R codes itself from the beginning. So that document is called as an R script. So let's see how we do that. So the simplest way you can do it is you say file, new file, and R script. So you see here some blank pages opened. And here you can start typing. So here you can type, let's say, again, 2 plus 3. Here, when I'm pressing enter, it does not get executed, right? It's just like a Word document. You're just documenting it, and the line numbers are increasing just for an easy reference. I can always say, okay, please take a look at line number 2, take a look at line 5, and so on. If I do want to execute these statements, execute these commands, there are a couple of ways to do that. The first thing I can do is I can highlight that line, or I can just have my cursor on that line, and I can press Control Enter or Command Enter, depending on your operating system. So here I'm going to press Control Enter, and you see what happened is this thing, it sort of got pasted here on its own and it was executed, right? I could also copy paste the whole thing, but that will be just longer. The other option is here I have my cursor here and I can just press run. There's this run button here. So I can do that. There's also something, let's say I do want to add some statements to explain these things better. But they're not going to be commands. Let's say I just want to write, this is how we can use R as a calculator. I want to write this down. So this is not something that R would understand. R has nothing to do with it, but this is something I have added for my reference, so that the next time I open this document, I know what I was doing in the lines around it. So this hash symbol, just a single hash or multiple hashes, they make what's called as a comment. And this is recommended that you use these comments, right? So for today's discussion, I have already made an R script, and I will just open that here. So I'll use file, open file. I will navigate through the folder. So it's already opened here. And you can see here, I have a document which has the extension .r, and I've just named it week 1 R basics. So I'm going to open it. And you see here, I already have a large document with some 180 lines in it. And there are a lot of comments, the ones that you see in green here, and I have a lot of commands also, right? So I will quickly walk through this since it's a re-recording of the session that was already conducted. So here you can do the basic calculations with the power. If there are multiple operators being used, then BODMAS is going to be followed. So for example, in this one, first you are going to multiply, that gives you 30, and then 4 minus 30, that's going to give you 26. So just to give you a demo, I have my cursor here and I'm going to press Control Enter. So what's going to happen is that this is going to get pasted here and executed at the console, right? So I press Control Enter and I got the output minus 26. Then for something like this, so if you in maths, you have these three brackets, right? The curved bracket, which you can see here. Then you have the curly brackets and the square brackets. In R, whenever you're doing a mathematical operation, you are only going to use curved brackets, not the other brackets, because they are reserved for some other operations. So you have as many number of brackets you may want to use, but you will only be using the curved brackets here, as you can see here. So I'm just adding a comment that R understands only curved brackets in mathematical operations. All right. Okay, fine. So if I run this, I got the output, and you can check that it's what you would also get when you use it through BODMAS. All right. Now, you've executed these things, but let's say you would like to save that output somewhere. Currently, if I have this with me and I want to make, I want to add some numbers to it, I'll have to retype the whole thing. But what I can do instead, I can save this value to this R session. So the way I want to save it is I can assign that value to a variable. Typically, a variable would be alphabets, some single alphabets. You can have words. They would not have any spaces. They would not have any special characters in them. They're going to be simple words: A, B, C, D, A1, A5, temp, L1, whatever. Okay. If you're using a lot of variables, it's recommended that your variables are a little informative about what they are doing. So typically when you would make a graph, it would be good to have X and Y as the variables. Or if you have variables that indicate something. So let's say you can say age is the variable, height is a variable, month is a variable, something like that. So here, when you want to assign a value to a variable, what happens is the value on the right side is stored in the variable on the left side. And there are two ways to do it. You can either use the is equal to symbol, the simple one, or you can use this arrow, the arrow which is pointing to the left. And this arrow is made up of the less than symbol and the hyphen. Okay. And this is actually called the assignment operator. But both the statements are doing the same thing. Whatever value is there on the right, you save it to the left. So I'm going to execute the two lines. I can highlight them both together. I can press Control Enter. And when I do that, you can see here that in the global environment, there are two values now stored. So 3 into 6, which is 18, it got stored into A. And 4 plus 9, which is 13, it got stored into B. Now I can do some operations on these variables itself. So I can do A minus B, and I get the value 5. I can do this operation, I can save that value into another third variable. So when I execute this, there's no output here because the value got actually saved into this variable C. Also, R is case sensitive. So now I have small a as one of my variables, but now I can also have capital A as another variable. So R is case sensitive. Also, you can see here that in some examples, I have a space before and after some letters. In some examples, I don't have a space. So whether or not there is a space between values and between operations and operators, it does not matter. So space does not matter in R. Now, currently what we are seeing is mathematical operators, but sometimes some operators are also inbuilt. So let's say there's something called finding the square root, right? So if you want to find the square root of a number, one way to do it is you can say that that number to the power 0.5, that gives you the square root, which is correct, right? So 81 to the power 0.5 and you get 9. There's a function, an inbuilt function in R, which is called SQRT. So functions will have some name with it, and functions will always be followed by a curved bracket. So this is the second use of the curved bracket. The first use is for mathematical operators where you actually have that bracket. And the second and the more important use is actually at functions. Every function is going to be followed by a curved bracket. Whenever you see a curved bracket, it's either a mathematical operation or a curve or a function. And I am emphasizing on this because this is important. All right. So I have the function here, SQRT. I have the curved bracket. And within that curved bracket, I give it the input. I give it an input, I give it an argument. It's the same thing. So here I'm saying the input or the argument is 81. And I press Control Enter and I do get the same answer, right? Likewise, there are some more functions that were discussed. So one function is sum. It is analogous to using multiple plus symbols. So you can do 60 plus 21 plus 30 plus 40, or you can give multiple inputs to the function sum. So when you do that, you get the sum. Likewise, there's another function which gives you the product of all the numbers. So when you do that, you get the product of these numbers. Sometimes you may want to find the absolute value. So what the absolute value means is if it's a positive number, you get the positive number back. If it's a negative number, you still get the positive number back. All right. Just a second. Yeah. Okay. So when I want to find the absolute value of minus 134, it's going to give me 134. And so we've seen how you can store values or you can assign values to variables. All right. So the next thing, so here what you can see is I'm only storing one value to one variable, but sometimes I might want to store multiple values to a variable. Okay. When you store multiple values to a variable, one after the other, that sort of a variable is called as a vector. And there are three ways in which you can make a vector. The simplest way is where you tell one by one what each of the values are that you want to store. So let's say I want to store the first 5 odd numbers, which is 1, 3, 5, 7, and 9. So the function I'm going to use is the C function. The name of the function is C. It stands for combine. So I have the function C. I have the curved brackets, and then I'm going to write the 5 values here. And then I'm going to store it with this assignment operator to the variable L. So when I run this, you see here, the variable L is now present in the environment, and it says it has numbers in it. There are 5 numbers, and these are the 5 numbers. Now here you can see that there is a square bracket coming up. So a square bracket is used where you have, which is used to access elements when a variable has multiple elements. So in each of the first 4 cases, there's one variable and there's just one element or just one value in it. So I don't need to access anything in particular. When I say A, I will get 18. Or when I have capital A, I will get 100. But when I say I have L, sometimes I might want all the 5 values. Sometimes I might just want one of the values or 2 of the values. So to access any value within the square bracket, I can mention the index. And in R, the index begins from 1. In some other languages, the index may begin from 0, but in R, it actually begins from 1. So the way it's going to go is if I write L and if I write a curved bracket, if I write a square bracket and if I write 4 in it, it's going to give me the 4th element. So when I run this, you can see I get 7, which is the 4th element of this vector. There's one more way. So in yesterday's session, somebody has asked that, well, I know that odd numbers differ by an increment of 2. So can I just directly say that I want all the odd numbers between 1 and 10? Which was a very good question. So the way you can do it is there is another function called seek. And now seek accepts multiple inputs. So each of the inputs has a name of it, right? So that there's no confusion, so that the function understands that, okay, these are the 3 inputs and this is what each of the inputs mean. I can jumble up the inputs also, but as long as I have this name with it, R is going to understand it correctly. So these are named inputs or named arguments. So the way it's going to work is within seek, within the bracket for seek, I'm going to write from, So start from 1, 2, so go until 10 and go in jumps of 2. So you start with 1 and then you go to 3 and then you go to 5 and then you go to 7 and then you go to 9. But then you don't go to 11 because you said you're going to stop at 10. So when I run this, I get the same output. So this was simpler than actually calculating and writing each of these one by one. Because let's say if I wanted odd numbers between 0 and 100, or like between 1 and 100, it would be very tedious for me to write 1, 3, 5, 7, 9, 11, and so on. But this, on the other hand, is going to be simple. I can just write 1 to 100 by 2, and I'm going to get all the odd numbers. Likewise, I can also do a decrement. So I'm going to say you start from 100, you go until 1, and you decrease by 2. So when I run this, you can see here that 100, 98, and so on. Another thing we discussed was that what do these square numbers here indicate? And as some of the students in the live session pointed out, that these are the index of the first element in each of the lines. So just to make it clear, if I increase the size of this output window, now you see this numbers have changed because this 100 was the first element, no doubt. Then 68 here is the 17th element. Now you see 68 is here. This is the 17th element. 18, 19, 20, 21, 22, and 23. So 56 becomes the 23rd element. So these numbers, they are not the output. They're just giving you sort of a line number or an index number for the numbers, for the outputs, just to make it a little more legible. Okay. Third way to make a sequence or a vector is, this is only going to be used when you are talking in increments of 1 or decrements of 1. So here you can have the colon. So 6 colon 10 or 10 colon 6. And as you can see from the outputs, it's just giving you consecutive numbers, either increasing or decreasing. Now, when we talk about these vectors, there is a length associated with it. So the number of elements in that vector is called as the length of that vector. So the function length can be used to tell how many elements are there. So when I do length L, I'm going to get the value 5 because there were 5 elements in this. Now, when we talk about multiple elements, you have to be slightly more careful when you are doing operations with this. Simple multiplication, addition operations can be calculated incorrectly if you're not careful about elements. So let's see what I mean. I'm defining 4 elements here, A1, A2, A3, A4. Now, as you can see here, A1 has length of 6, so it has 6 elements. A2 here, if you see, that also has 6 elements in it. A3 has just 3 elements and A4 has 4 elements. So if I do a addition on 2 of these vectors, so on A1 and A2, this is going to be an element-wise addition. Or if I do a multiplication, it's going to be an element-wise multiplication. So you have 6 elements and you have 6 more elements. Element by element, they're going to be multiplied or added. So here it's going to be 4 and 1, then 5 and 2, 6 and 3, 7 and 4, 8 and 5, 9 and 6, and so on. So if I do that, you can see the outputs, right? So 4 plus 1, 5 plus 2, and until 9 plus 6. When you do a multiplication, again, they're going to be multiplied element-wise. This is not, so somebody had pointed out, if it's like the dot product of vectors, so it's not like the dot product of vectors. This is element-wise operations. We will, if at all, we'll be talking about dot products later on, but not right now. So now this was the case when the two vectors had the same number of elements in it. Now, what if I multiply or I add A1 and A3? So you can see here, A1 and A3 have different lengths, but there's a catch here. A1 and A3, one has length of 6, the other has a length of 3. So what can happen is 4 and 0 can get added, then 5 and 3 can get added, 6 and 5 can get added. Now after 7, 0 is going to get added, 8 and 3 are going to get added, and 9 and 5 are going to get added. So the smaller one gets repeated. So what happens is you still get an output, you don't get a warning, you don't get an error, you would see that, okay, things have worked perfectly fine. But if mistakenly you missed some element in A3, maybe A3 was not supposed to have 3 elements, maybe A3 was supposed to have 6 elements, but you missed them. So the answer is actually incorrect. Now, another operation, this one. So if I do A1 plus A4, now what happens is, again, for the first 4 elements, it's perfect. For the next 2 elements, only the first two elements of A4 are going to get repeated. So what happens is it still gives you an output. So 4 plus 2, 5 plus 5, 6 plus 8, 7 plus 0, then now 8 plus 2, 9 plus 5. You still get the output, but you also get a warning message, which says that in this operation, the longer object length, which was 6, is not a multiple of the shorter object length, which is 4. Okay. This is what we already saw, that if you want to access some specific element of a vector, if it's just one single element, you can just write the element number, the position of the element. So in this case, when I say 4, it's going to give me 7. But now if I want to access multiple numbers, I want to input, so I want multiple positions to be accessed. So the way I'm going to do it, I'm going to make a vector of the positions I'm interested in. I want to access elements of a vector. I want to access multiple elements of a vector. So I'm going to make a vector of the positions that I want to access. So this is a vector, right? C3, 5 is a vector. It has a, so what this whole thing is going to give me is that I want to access the third and fifth element of the vector A1. So the third element is 6 and the fifth element is 8. Right? Cool. We've already discussed these brackets. The use of curly brackets is going to come a little later, so we will discuss them as and when that happens. Now, there's just something more about vectors that I would like to mention. It was also discussed in the lectures. So there are 3 ways in which you can give an input to any function. So let's say I say 1 here, I redefine A, and you can see that the value has now actually, it's now been overwritten. Earlier, I think it was 18, but now it's overwritten to 1, 2, 3, 4. So I assign this vector C1, 2, 3, 4 to A. Now to the function max, which is going to give me the maximum value, I can input A just as it is, or I can input the vector also, which is actually the same thing, right? So here I have 4 numbers input as one vector. In the second case also, I have 4 numbers which are input as a single vector. In the third case here, I actually have 4 different inputs, right? Because they are not bundled together as a vector. I don't have the C operation or the seek operation or the colon here. I just have these as 4 different inputs directly to the function max. So let's try and execute the 3 commands and see what we get. So you can see here in all 3 of them, we get 4 as the answer, which is correct. So there was no problem here. Now in case of mean, let me execute the first 3 lines here. So now you can see here mean of A, 2.5, that's correct. Mean of the elements of the vector, that's also 2.5, that's also correct. But when I did mean of 4 numbers, it gave me 1. So another example, if I have any 4 numbers, it gave me 3 here. So what it's actually returning is just, it's giving me the first element. It's ignoring the next elements, it's ignoring the next inputs. It's just taking the first input and it's considering I need to find the mean of the first input. Now here also you see this is the first input. It's the only input, but it's also the first input. So functions like this are able to accept only one input and it will perform action on that input. So here the mean of 1 was 1, the mean of 3 was 3, but that is incorrect. So whenever you want to input multiple values, it is always recommended to input them as a vector rather than as individual numbers. Also, just want to show it with this another example. If we do that for the square root, so square root of A, this is actually finding square root of each of the 4 elements of A, and it's also doing that same thing for the vector when it's specified with the C function. But in the last case, it's saying that there are 4 arguments. Right? 4 inputs are passed to SQRT, but it only requires 1. So just be careful. So when you're working with vectors, be careful about the lengths of the vectors, especially when you are dealing with 2 vectors together. They should have the same length, or if they have different lengths, then you should be you should know that this is what you are expecting. And the other thing with vectors is when you're inputting them, you should input them as vectors, not as individual elements. All right. So now we move on to a slightly different topic and we can just make a scatter plot here. And this will also give you an idea about something called mandatory arguments or optional arguments. When you want to make a scatter plot, which is the simple XY points, you only need the X and the Y coordinates, right? When you make it on a graph paper, if you have X and Y paired values, like for every point you have an X and Y coordinate, you can plot those points. You don't need anything else, right? So let's say I'm defining X and Y here. You can see them in the global environment. There are 10 numbers here, and I can plot them with the plot function. So plot function, curved brackets, it accepts two inputs, X and Y, in that order. So I can increase the window size, and now it looks a little better. So you can see here, right? You have the X and Y labels. So I did not have to specify anything else. By default, it did not give me any heading. By default, there were no colors. The symbol was an open circle, and it by default gave me just points. It did not give me any line. But I might want to change this. So I can add a few elements. I can add a few arguments to my function, which it understands, and then my graph might look a little different. So there's an argument called main. It's a named argument. So I'd say main is equal to, and I give it a heading, a title. So when I execute this, you see the graph stays the same, but it's just a title has been added. There are a few ways in which your graph can look. So here it's a scatter plot, which is made when you have P written here. So just want to, so what you can do is in the help menu, you can type the name of any function, press enter. It's going to search. Another way to do it is in the console itself, you can type question mark and that function, and it's going to open a topic. You can choose which one it is. And now you can see here, it says X and Y are mandatory arguments, but everything else is like ... You can play around with these. So type here, which I have not specified, but type is pretty much the third argument always. So even if you don't say that, it's understood, but it's always actually better to write type is equal to in all of these cases. So you can do, so you can specify this as, if I do P here stands for points. If it's L, it's going to give you a line. If you say B, it's actually going to give you both points and lines. If you say S, it's actually going to give you steps. So a step means from one line, you do a horizontal line, and then you take a vertical line to the next point, horizontal, vertical, like that. And then if it's H, it's actually going to be a histogram. So depending on what you would like to show, what you would like to depict through a plot, you can decide what type of point works best for you. All right, and then there is an option to export or save the images. You can save them as image. You can specify what extension you want, which folder you want it in, what should be the name. You can increase or decrease the relative dimensions, and then you can press save. So it's going to get saved on your computer. Or if you don't want to save it, you can just copy it to the clipboard. Again, change the dimensions, copy it. It's copied. You can just do a Control-C anywhere, and it's going to get pasted. All right. So now you did mathematical operations. Sometimes you might want to compare numbers. And we're talking about 6 comparison here. Greater than equal to, less than equal to, equivalence and non-equivalence, right? So you can see that here, 5 greater than 9, 5 greater. So each of these operations, they are called relational operators, and the output is going to be true and false. That's the only option possible. So 5 greater than 5 greater than 9, it's false. 5 greater than equal to 9 is also false. 5 less than 9 is true. 5 less than equal to 9 is also true. For equivalence, you cannot use a single is equal to, because a single is equal to is actually an assigning operator, right? It would assign the right hand side to the left hand side. Because if you do something like this, 5 is equal to 9, that's actually going to give you an invalid error, right? It's just going to say it's invalid. So instead, you need to use the double is equal to check if they are equal. So are 5 and 9 equal? No. And then to check for non-equivalence, you do an exclamation mark followed by is equal to. So are 5 and 9 not equal? Yes, they are not equal. Likewise, here you can also do checks on the variables you already have saved. So let's say I want to compare these variables B and C here. I want to compare. So is 13 greater than 5? I'll write is B greater than C? Okay, this is an error because of this, but so I'll just run it again. Yeah, so B greater than C, that's true, right? That's correct. I can also do this on vectors. So what I did here, let's say I have one of the vectors A and I'm using B here. So it's comparing each of the elements of A with B. So here you see I get 4 outputs. 1 greater than 13 false, 2 greater than 13 false, and so on. Now I had these relational operators, right? If you're familiar with the concept of AND gate and OR gate, you can compare 2 true and false statements. And depending on if both of them are correct or if either of them are correct, you can choose what should be the output of that. Are you interested in cases where both the cases are true only? Or are you interested in cases where having one of them true is enough? Or do you need cases where both of them are false and things like that? So the AND operator here, so true and true. So out of these 4 cases, when both statements are true, only then you get true. Otherwise, in all other cases, you have false. In terms of the OR operator, which is denoted by this pipe symbol here. So AND is using the ampersand and OR is using the pipe symbol, which you have just below the backspace and just above the enter. So here in this case, you would have when even if one of the statements are true, your output is going to be true. But when both of them are false, you get false. So here 5 greater than 9, that's false. 9 greater than 0, that's true. So a false and a true statement, since it's AND, it's going to give you false. But when you have both true statements, it's going to give you true. All right. With this, we come to the end of the mathematical aspect. There's one more command which would be used more in detail from the next week onwards. It's the sample command. So it is following the lines of random number generator. And it's like the simple example where let's say you have a bag and you have 100 balls in it and you want to pick 5 of them. So you pick one, you pick second, third, fourth, and fifth. Or the other way you can pick them is you pick one, you put it back in the bag, you shake it up, and then you pick the second ball. So the first case is the example of no replacement or without replacement. And the second example where you are placing the balls back, they are an example of with replacement. So what you specify here is that what are sort of the numbers that you want to choose from. So I want to choose from 1 to 100. How many numbers do I want to choose? I want to choose 5 numbers. And do I want a replacement or do I not want a replacement? So just to show you again here, you can see that by default, the replace argument is set to false. So whether you write the entire word false or whether you just write capital F, likewise, you just write capital true or you just write capital T, it means the same thing. It's a matter of preference. So by default, it's false. So when I don't specify anything or I specify it to be false, it will understand that it's without replacement. So now since it's a random number generator, so even if I execute the same line multiple times, you see I'm going to get a different outcome every time. Or let's say even if I execute this one, just the first statement. So you see I have the same line thrice, but I got different answers every time. This is what you want, right? Every time you pick 5 balls, you're going to get different 5 balls. There is a way to fix how the randomness is being generated, which we will discuss in the next week. But so yeah, so this is how you can pick numbers, sampling with and without replacement. And then there's just one more thing that was discussed. So R is used in a lot of different fields. And the functions that you saw until now, right? All the functions that you see with these curved brackets, they are relatively basic functions. So if you see here, there's this thing called base, which means that when you installed R on your system, you installed some functions which everybody uses almost every time. You would use most of those functions because they're basic functions. But there are going to be certain functions which are specific to a particular field. right? Particular to stats, particular to, let's say, bioinformatics, particular to economics, and wherever R is being used. So people have sort of bundled together related functions into packages, and you can install those packages. So what you do is, as such, when you're running R, you don't need you don't need to you don't need internet connection. But when you want to install a package, you can install it from the internet, and now that's those packages, those commands, they're now in your computer. So now they can be accessed without the internet. So to install that, you can either use the command line and do something like install dot. Oh, by the way, you might also come across this thing that in RStudio, when you have typed 3 alphabets, it gives you certain options that it's able to predict what all you might possibly want to type. You can either choose from this, or you can continue typing on your own. So I can just select, because it's simpler to see. It's not easy to remember always whether you have a dot, whether you have a capital letter somewhere or the other. So just typed it, and within the bracket, I write double quotes and I type the exact name of that package. So let's say there's a package called Painter. So I can run this, and it's going to say, okay, trying to install, and then the downloaded this thing is in your computer. Another way to install is you go to packages pane here, you press install here, and you type the name here. So ideally, you don't need to install a package again and again. So Painter is already there in my computer, but it's reinstalling it, which is okay. So I can do that. I can press install, and you see now it's typed the exact same function. So I had already typed this the previous time I showed you, and now it's installed here. But I cannot use the functions in this package just like that. I need to call that package, or I need to load that library before I can use it. So again, there are 2 ways to do it. Through command line, you can use the function library. In bracket, you can type the name of that package, this time without the double quotes. Or the other way I can do is, so you can see here, there is a tick in some of the packages, but there's not tick in most of them. So this shows that all the packages whose name is here, they are installed in my computer, but only the ones which are ticked have been loaded in the R session for today, because it is going to use RAM, right, when it's installed. So when it's loaded. So let's say I want to install, I want to load this one, ggplot. It's for more fancy plots. So I can just press a tick here, and what it did was it just loaded that library. Again, your choice whether you want to do it through the ticks or you want to do it through the command line. Demo is another function that can give you a demo of a lot of these things, right? So you can just write one of these options available here. You can press enter. So what it's going to do is that it's just going to make it's a pre-written demo. It's going to make you plots. It's going to add things in your global environment. Yeah. So I can keep running this, and you can see some new variables are being created here. I'm just pressing enter to keep seeing this. All right. So, all right, that's there. And then you can remove some variables from your environment if you want. So it's the RM function, and within the RM function, you write the name of your variable. So if I press this, you'll see that this variable A actually goes away. It's deleted. There is also this broom option here in your console, on the plots page, and in the environment. You press any of them, and anything that was present there goes away. Word of caution, be careful while doing that. It is always good to maintain such a script that we have here. Now I made some changes, so you can see it has an asterisk now next to it, which means it's not saved yet. So I can press Ctrl+C and it gets saved. And then this is what I have already uploaded to the Google Drive. Just one final thing before we complete the session. So you would have seen that in this week's assignment, there are a lot of questions which look like some basic maths questions with they're written in the form of R. So there are two ways you can do it. One is you can directly type this into R, get the output, select the right option. The second thing is you actually try and calculate it using pen and paper. So the way your final exam is going to be conducted is going to be, it's going to have similar questions as in your assignments, but you would not have access to R. Neither R nor RStudio. You would have a scientific calculator available with you in case you want to, calculate these things like that, simple powers and exponents and things like that. So I will recommend you to solve these questions both ways. You first try to do it on paper. Also try to type this into R, which will give you a better hand at how to type into R, with what mistakes you might make. Sometimes you might miss brackets, you might make spelling mistakes, you might forget some mathematical operators here and there. So it's going to give you an error, but it's going to be a good learning experience. It will take a while, but you will get the hang of it. All right. So just another thing, in this week's assignment, question number 10 will not be evaluated since there's a duplicate option available in that. So you can skip that question. It will not be evaluated. So your marks will be out of the other 14 questions. And this recording, it's being recorded now. So I'm going to upload it to YouTube. The material we discussed today, which is the PPT and the R script, they have already been uploaded to this Drive link. Typically, your weekly assignments, this one should have the submission on the 31st of Jan, but since it's the first week, people might join late. So the deadline for this week is 7th of Feb. 7th of Feb will also be the deadline for submitting week 2's assignment. So the sooner you do it, the better. And I will see you next Friday on the 2nd of Feb, same time, 6 to 8 p.m. Also, there are going to be 2 live sessions for this course on Saturday, 3 to 5 p.m., 27th of Jan, and on Tuesday, 30th of Jan, 6 to 8 p.m. So you can attend any of the sessions. You can attend 1, you can attend 2, you can attend all 3 of them, and whichever one works for you. Recordings would anyway be uploaded. So if in case you miss any of the sessions, you can go through the recordings. So I think that is all I had for today. Thank you. I will see you all next week.